Okay, so if you want to solve this system of equations, notice that both of the equations, it says y equals and y equals. So what we're going to use is the fact that y is equal to y and then just make a substitution. So I can replace this y with 6x plus 35, and I can replace this y with 9x plus 14. Okay, so essentially I'm just setting them equal to each other. Now I'm ready to move the letters to one side, numbers to the other. So I'm going to move the 9x to the other side by subtracting it. And at the same time, I'm going to move the 35 to the right side by subtracting it. Okay, so 6x minus 9x is going to give me negative 3x. And then those are gone. 14 minus 35 is negative 21. Divide both sides by negative 3 to get the x by itself. And negative 21 divided by negative 3 is positive 7. Okay, from here, it doesn't matter which one of the original equations you go to. So I could grab the top one or the bottom one. It's your choice. You'll get the same answer either way. So I'm going to, for no particular reason, grab the y equals 6x plus 35. And now I'm going to replace the x in this equation with the number 7. So if I replace the x with 7, following PEMDAS, 6 times 7 is 42, and then add the 35, and I have 77. Remember, when you're solving this system, these are both lines, and so this is a coordinate. This is the point where both of these lines intersect. So you could list it as a point 7, 77, or you could state the x and the y. Okay, so just one more example here. Y equals 2x plus 56 and y equals 9x. Using the fact that y is equal to y, I'm going to replace this y with 2x plus 56 and this y with 9x. I'm ready to move letters to one side, numbers to the other. So if I subtract 2x, I'll have all my x's on the same side. 9x minus 2x is 7x. To finish getting x by itself, I'm going to divide both sides by 7. And 56 divided by 7 is 8. Go back and put it in either one of the original equations. You might as well pick the one that you think is easier. I was thinking y equals 9x seems like the easiest one. So I'm going to replace the x with 8. And 9 times 8 is 72. Again, remember that these are both lines and the solution is the point that they have in common. So it's where these two lines intersect. So if you wanted, you could say that it's 8, 72, the coordinate, or I could just say the x is 8 and the y is 72. Now something else that could happen is if these lines were parallel, then we would have no solution. And what would end up happening in the equation is when you go to move the x's to the other side, all of the x's drop out. So for example, if I subtracted 2x and I subtracted 2x, then maybe both of these are gone and I have 0 equals 56. So if everything drops out, it's a special case. And if it drops out and you get a true statement, then it's infinitely many solutions, like 0 equals 0. But if you get a false statement like 0 equals 56, then it's no solution. And what that really means is the original equations were parallel. If you know a little bit more, you could skip a whole lot of work, because if the slopes are the same, then the lines are parallel. So from the very beginning, if I noticed that the numbers in front of x were the same number, then I would know that the original lines were parallel, and I wouldn't go and do all of this work. I would just immediately say no solution. Okay, so I'm going to say that one more time. If you at the very beginning notice that both of the numbers in front of x are the same number, that means they have the same slope, and lines with the same slope are parallel, they will never cross. So before I do any work at all, I would already know that it's no solution.